Welcome to this video on closures. Closures is one of the most complex and sophisticated aspects of the JavaScript language. It rests on a deep understanding of lexical scope, of our persistent lexical scope reference, of exactly what it means to return a function definition from another function. We get those principles down in this video and we have a strong, intuitive understanding of closure. What does closure let us do? Closure lets us build functions that remember their previous execution. They get a persistent cache, a persistent memory alongside. We're going to discover that lets us build functions like once and memoize. Very, very powerful tools in our JavaScript toolkit. So I welcome you to this video and I look forward to seeing the things we're going to build using closure. So, in our previous session, we saw the power of passing functions in to other functions to make them reusable. Today, we're going to see what happens if we give our functions memories. If we allow functions to somehow, between their executions, remember their previous state, their previous data from past runnings. That's going to give us superpowers in writing our code. It's going to allow us to create functions that like once. It's going to say you can only run me once. So it's a once-ified version of multiply by 2. You can only run me once, and after that, if you run me again, return out, sorry, you can only run me once, or something like that. If we have that, our functions have memories. They have some way of remembering the previous time they were run. We can do all sorts of very interesting things. Normally, note, when our functions get called, we create a live store of data inside of them, sometimes known as variable environment, local memory, state, the data, the state of the function, for that function's execution context and only for the life of that function's execution context. That means while it's running, before it finishes executing. When that function finishes executing, everything gets deleted, except what? What doesn't get deleted?
The return value.
The return value, exactly. All the other local memory of the function is deleted. But, as I say, what if our function could remember the previous times that it was run? What if somehow some of its data could be held onto and not deleted? That would give us these supercharged functions that have memories. Right now, functions start from scratch every time you run them. You run it, finish it, start from scratch, run it again. Now they could get memories. This would allow our function definitions to have an associated cache persistent memory, but it all starts with us returning a function from a function. That underlying understanding that can be very confusing, we get this down, this profound concept of closure becomes much more readily understandable. So, functions can be returned from functions in JavaScript. We saw that at the end of our high order functions session, where we noted that passing in a function or returning out a function was possible in JavaScript because functions are just objects. And we know we can pass objects around, so no problem. Well, let's see this precisely line by line. So, we have here a function instruction generator, which we're then going to call and store its returned value, whatever gets returned out of it, into generated func. Let's start at the top here. Lewis, kick us off. What are we doing?
We're declaring a function called instruction generator and storing it in global memory.
Beautiful. There it is. Excellent. Mejan, next line.
We are declaring a variable called generated func.
There it is. Excellent. And what is going to be stored in it, Mejan?
The return value of invoking instruction generator.
Fantastic. That's very good. Now, Philip, can you do as well? What do we do when we execute instruction generator? What happens?
We declare a function, multiply by 2.
Before we jump into the function, what do we create?
A new execution context.
He did very well as well. Very nice. There it is. A new execution context, which represents or is the space, the context, the space in which to execute the code of the instruction generator function. This code here. We didn't write it out here, but it's in there. We're going to run through that code line by line and store anything that gets declared in a little local memory just inside this function. And by the way, when we finish running instruction generator, when we return out, all this stuff gets thrown away, gets deleted, gets removed. Huh. Also we think. Right, in we go. What is now, Philip, you're right, what's the first thing we do inside of this function?
We declare a function multiplied by 2.
Multiply by 2, yeah.
Store it in local memory.
Yeah, and it's stored in local memory, not in global memory, note, right? It's stored in local memory because we're declaring it inside of instruction generator. Now, Mejan, do we execute that multiply by 2 function at this point?
Not yet.
No. What do we do instead?
We go to the next line that will be run, which is return multiply by 2.
And are we executing it there?
No.
No, we're definitely not. We are taking the entire function definition and we are returning it out. We are returning it out, not with its name, just the function definition. We're returning that function definition out, and it looks a lot like this. Return function, no name. Well, it has, what is it? Num, yep. And then return num by 2. This whole function definition, this whole function definition, this whole function definition is all getting returned out into what global variable z?
Generated func.
Into generated func. A placeholder happens to be a variable, but it's a placeholder where this function is now stored. Okay, this function which we returned out, the functionality formerly known as multiply by 2, we grabbed it all and it's now stored as the output generated instruction generator, and we stored it in generated func. So, Philip, what is generated func at this point?
It's really multiplied by 2.
It's the functionality we used to call multiply by 2 inside of instruction generator before we returned out that function definition, that functionality, that set of instructions, returned it out and gave it a new global label. Because inside it was known as multiply by 2. But that line return multiply by 2 says, JavaScript, go look at what multiply by 2 is. Oh, it's this function definition, return that out. There it is, return it out. Well, we don't return out its label. We return out just its definition. So we've got to, the calling of instruction generator returns out the functionality known as multiply by 2, but it doesn't get the label with it, so it gets a new global label, generated func. So now, Lewis, how could I, out here, this is the functionality formerly known as multiply by 2. Lewis, now out here, how could I refer to the functionality that was inside known as multiply by 2, how could I call that function out here in global execution context?
You could run generated func by adding parentheses.
I could run generated func by adding parentheses. And I probably want to pass in something, right?
Some sort of argument.
Which would be probably like a, let's say 3. Because generated func is the functionality we define inside of an instruction generator called multiply by 2, which we then returned out into the global variable generated func. There it is. Yes, it happened to be like a variable, but it can be whatever functions can be stored under this label here, and instantly generated func can now behave as a function. All right, let's keep track of our execution contexts. That means the calls to functions. We started off in global, and then we started running instruction generator. So we added the call to instruction generator on top of our call stack. What told us, Philip, that we were ready to pop the call to instruction generator off our call stack?
The return.
Aha, so we exited instruction generator and returned out to global. We knew that because when we got rid of instruction generator, what was top? Well, it was global. Perfect. It was global. We returned back out to global. And what happened to our execution context? It was done. Gone. Clear. Finished. And the only thing that stuck around was the function we returned out. All right, because we returned it out and gave it a new global label, generated func. So, as Lewis said, if I now want to run the functionality formerly known as multiply by 2, I don't panic. Even though multiply by 2's label, this was deleted, this is gone, I don't panic because out here I have a new label for it, generated func. So, talk me through that line, Z. We now hit our line, the call to generated func. Talk me through it. What happens here, Z?
We're invoking the formerly multiply by 2 function,
Under its new label.
which is generated func.
And we're going to assign the return value of this function to what global variable?
To global variable result.
Perfect. For now, result is...
We pass in 3 and then...
So for now, result is undefined. And we're calling generated func, which is formerly multiplied by 2 with input of 3. We create what? A new...
Execution context.
Good. Excellent. There it is. A new execution context. Into it we go. And the first thing in local memory, Z, is what?
Num.
Say it
We
again?
declare the variable num.
Num and assign, well, declare not the variable, the parameter, and assign it the value?
3.
3. Excellent. Very good. Okay, and then we do what? Num by 2 or something?
We're returning num multiplied by 2, so return 6.
Return out 6 into result. Excellent. There it is. Folk, this is very strong. What have we done here? It looks pointless to me. Why did we do this? What have we done here? We have created a function instruction generator. There it is. We create a placeholder generated func, which is going to be whatever comes out the bottom of the instruction generator. It could be the number 3, could be a 10, or could be a function. Well, we're going to find out. We call an instruction generator. We go inside. What's it tell us to do? It tells us create a new function. Multiply by 2. Do we run it? No. Instead, we grab it, the whole definition, return it out. Store it in generated func. Now we have that functionality formerly known as multiply by 2 in a new global label, generated func. Meaning we can now call that functionality out here. We can run it by its new global label, generated func. But it's really just a functionality of multiply by 2. Take in num by 2. Run it, take in 3, return out 6 into result. Let's have thumbs on what we've done here. Or before we do that, let me ask you this. What if I put parens on the end of this multiply by 2 here? What would have happened instead there, Meejan?
It would have invoked multiply by 2 and then returned the return value of invoking.
Very nice. So let's play that through. So put parens on the end. Let's not put an argument. So we're going to have num is going to default to undefined. Undefined by 2 is not a number, I think. NaN, I think. So we're going to therefore return NaN from instruction generator, not a number. So generated func will be NaN. And so down here we'll have not a number trying to be invoked. And finally, we might get an error at that point. This is one of the challenges of JavaScript's way of handling data types. Rather than restricting us early on and saying, no, I want this to return a function, so you can't return anything except for a function. It goes, no problem, very happy you want to return not a number, this seems a very reasonable idea right now. And then only when it finally tries to run it, 4 sort of steps later does it finally spot. This is why error handling in JavaScript can be hard. That's why there's something called TypeScript that is a more restrictive version of JavaScript that says, you've got to specify your data types as your inputs, your outputs, what particular variables will be, and do not try and modify them, otherwise you will have trouble. All right, so nevertheless here, my biggest question, let's do thumbs. I have something I want to see people spot, which is, well, let's do thumbs. You lost me, I'm clear, clarifications. Everyone's thumbs. Philip has one. Philip, what's your clarification?
Why are we doing this? It seems like it's repetitive to declare a function inside of a function, then return it out just to call it like
why are we doing this? Why are we declaring a very usefully, explicitly named function multiply by 2 inside of another function, then returning a little baby function out, and then calling it again anyway? Why not just declare multiply by 2 in the global memory from start? Well, it turns out we're going to get a whole bunch of bonus features by defining, by storing our function inside of local memory, and then returning it out. we're going to get a whole bunch of bonus features attached to that function.